Anything for me? Anything? If you remember something, please stop me. So we have x squared minus y squared equals 4. And it's asking us to determine the center, the transverse axis, I'll explain in a minute, vertices, foci, and asymptotes. Graph each equation. I don't like the way the book presents the graph, as I mentioned last time, but it was very quick in the last couple of minutes, so I'm going to review everything I said last time. I don't like the way they graph it. It's I don't consider this an appropriate method. Okay, so like we did with the ellipse, of course, we have to divide both sides by 4. We have to have 1 here. So this is x squared over 4 minus y squared over 4 equals 1. This is a nice situation in a way. So this is the a squared and this is the b squared. Right. Knowing that there is minus in front of y squared, not in front of x squared, we will graph a hyperbola that has the transverse axis horizontal. Because as you see, there is nothing subtracted or added to x or y. The center is 0, 0. We will get to those examples in which the center is not 0, 0. So x, or x squared in this case, has plus in front. Therefore, the hyperbola will have a transverse axis that is horizontal, and the two, so to speak, they're not, but the two parabolas, kind of, they will be facing each other. If minus sign is in front of x squared, then the transverse axis is vertical, and then the two, I don't know if I can I do this? Anyway, so the top branch will be opening up, and the bottom branch will be opening down. So at this point, we have plus in front of x squared. Now, we determine a and b because a squared is 4, and these are distances. Yes, I should write a squared equals 4. I take the square root, and I should write a equals plus or minus 2. But this is a distance, right? Anyway, so 2, and the same thing to 4b. I will create, and this is not part of the graph, I will create this rectangle, which in this case is a square. I will draw the asymptotes of the hyperbola. The asymptotes have to go through these two corners and the center. I don't want to put too much on the graph. The asymptotes will help us graph the hyperbola. So now I'm ready to graph it. The vertices have to be right here on the sides of either square or rectangle. And now I'm ready to graph the hyperbola. These branches have to approach this asymptotes, as we say, asymptotically. Closer and closer, closer and closer. And the same thing on this side. So this is this hyperbola. This equation is this. So we determine the vertices. So V1 and V2. So V1 has coordinates -2, 0. And V2 has coordinates 2, 0. Stop me if you have questions, please. Okay. These are the asymptotes. We graphed them already. If they are asking us to write the equation, that's fine. In this situation, we can determine that we have several points, but we can use the formula. So in this case, b over a, they are the same. So then y equals x, of course, because it's a square, and y equals negative x. So this line is y equals negative x, and we know we've used this a lot, y equals x. These are the two asymptotes. What else they said they wanted? So the transverse axis is horizontal, and it's basically y equals 0. So this is called, this axis is called transverse axis, and it's y equals 0. Okay. The center, we determined that it's 0, 0 at the origin. The vertices, we did that, and the asymptotes we did. So now we only want to determine the foci. And remember, this time, this is F1, focus 1, and this is focus 2. As you notice, this distance is bigger than A. Therefore, this is the relationship. For the ellipse, we had b squared equals a squared minus c squared. But now c is longer than a. So then that's why we have b squared equals c squared minus a squared. So b squared equals c squared minus a squared, and c will give us this distance till F2, or the negative portion, this distance till F1. So then c squared equals basically a squared plus b squared. A squared is 4, b squared is 4, so then c squared equals 8, or c equals 2 the square root of 2. So this is 2. 2 the square root of 2 is 2 times 1.4, 1. So it will be 2.8. So somewhere here. So this is F1 and this is F2. So F1 is negative 2 the square root of 2 comma 0, and F2 is 2 the square root of 2 comma 0. And we analyzed the hyperbola completely. There is nothing else we can find about it. Again, as I mentioned last time, the calculator, in my opinion, has some flaws with respect to the conic sections. And when we click hyperbola, this is the situation when h and k are 0 and when a is 2 and b is 2. So enter. Okay, so a is 2, b is 2, h is 0, k is 0. I don't like the fact that they don't show the rectangle, in this case the square. I don't like the fact that the asymptotes are not shown, and I don't like the fact that I cannot choose anything. Window, it doesn't allow me to change anything. It doesn't allow me to zoom in or zoom out. Nothing works. Nothing. I cannot analyze or zoom in, as I said, or determine points, or nothing, or check the intersection. It doesn't allow me to do anything. So I'm not very happy with the way the calculator presents this. Okay, back to anything else. So let's also look at one that has a vertical transverse axis. Any questions for me so far? Any questions? So let's say 4y squared minus x squared equals 16. Notice
actually,
that, yes?
Professor, I have a question.
Yes.
So a quick question. The asymptotes for the last exercise, it's always going to be from the corners of both points that we get.
Always. Absolutely, yes. Oh, sorry. So let me stop sharing. Always. So the asymptotes, we lost Wes. So the asymptotes will always go through the corner, and center. The center doesn't have to be the origin. If the central is here, it will still be the same thing. Because the asymptotes are b over a or a over b. So if it's this situation, it's b over a times x, negative b over a times x.
Okay, thank you.
Thank you. So that's how we determine the asymptotes. It's the b and the a, the a and the b. So b over a. So if you determine these corners or these two, and you'll see you have 2 points, you can determine the equation of the line. And this is what it's going to be. Yes, all the asymptotes have to go through the center, whatever the center is, not necessarily this, and definitely the opposite corners, always. Very good question. Is this okay?
Yes, Professor.
Perfect. Thank you. That's why I prefer. Yes. One other thing. The asymptotes and this rectangle or square, they're not part of the graph. Do they have to be graphed? Yes. The asymptotes, absolutely, always. Whenever we graphed anything that has asymptotes, we started with the asymptotes. I cannot start with the asymptotes. It's much easier to start with this square or rectangle and then graph the asymptotes. But the square can be deleted. So as I said, it's not part of the graph. The asymptotes are not part of the graph, but they have to be graphed. But this is helping me keep the graph in shape, but you don't have to delete them. You don't have to erase them. You don't have to, you can leave them alone. So this is how it should look like. I never delete the square or the rectangle. Good. So let's take a look on to the next one. Obviously, I see negative x squared. Of course, I have to divide by 16. I always have to have 1 on the other side. All ellipses, all hyperbolas, equations cannot be determined before 1 is just figure 1 is on the right-hand side or left-hand side, it doesn't matter, one or the other. You cannot determine anything. So I'll divide by 16. 4 divided by 16 is 4 minus x squared over 16. I'm going to write it again because I didn't. It's not in line. I always like to keep the fractions, the negative sign and the equal symbol all in the same line, and I put the equal symbol before I wrote the right hand side. So okay, so what I'm going to do, because I don't want it to have it good, so then in this particular case, this is the a squared, this is the b squared. So then a will be 2 and b will be 4. So when I start the graph, knowing this, basically here, better, knowing this, I know that b is 1, 2, 3, 4, 1, 2, 1, 2, 1, 2, 3, 4. I create my little rectangle that helps me graph correctly. And now this is one vertex, this is the other vertex, and here's the graph. The transverse axis is vertical. This is called the conjugate axis. Conjugate axis. Okay, and then we know that c squared equals a squared plus b squared. So 2 plus 4 is 8. Look at that. I'm sorry. 4 plus 16 is 20. So C equals 4 the square root of 5. So how much is the square root of 20? 4 times 2 is 8 something. Let's see. 4.5. So this was 4.5 is here. So this is the F1 and this is the F2. And this is V2 and this is V1. So V1 has coordinates -4, 0, -4, and V2 has 0, 4, no equal symbol, sorry, and F1. So 4 the square root of, so -4 the square root of 5 comma 0 for F1, and 4 the square root of 5 comma 0 for F2. Any questions? Okay, so let's look at one example. You choose, please, if you'd like. Find an equation for the hyperbola described. The center is different, is not 0, 0. Focus, we know it has 2. Vertex, okay, we also know it has 2. Or this. Or this. And let's move on afterwards. Any preference? 42, 44, 46. Anyone would like to pick? Okay. Say it again, 44? Okay. Perfect. So let's take a look at 44. It says the center is 1, 4. It says one focus is -2, 4, and the vertex at 0, 4. Because C, the center has y coordinate 4. The focus has y coordinate 4. The vertex has y coordinate 4. What do you think? Will the parabola have a horizontal transverse axis or vertical transverse axis?
Vertical.
So this is y equals 4. The central, the focus, and the vertex have to be on the same axis. Y equals 4 is a horizontal line. So let's put them together. We'll see in a moment. Okay, so we have 1, 4. So here's the center. Okay. Then we have -2, 4. So this is definitely F1. It's on the left-hand side of the center. Can anyone give us the other focus, which is F2? Remember, this distance is 3. 3 units on this side, mandatory 3 units on the other side.
Or 4.
So it will be, so we have 1, 2, 3. 1, 2, 1, 2, 3, 4. Excellent. I think my unit is a little bit wider here, but that's okay. Okay, so this is F2. Perfect. Now let's look at the vertex. So we have 0, 4. So this must be V1. Can anyone give us V2? So let me write here, F2 has coordinates indeed 4, 2. Awesome. 4 comma 4, sorry. Excellent, good. What about V2? So this is F1 and this is V1 from left to right. Can anyone give us V2? The coordinates of V2.
Would it be 0, -4?
So careful. So see, this is 3 units. This is 3 units. Now this is 1 unit. V2 has to be on the other side of the center. And if this is 1 unit, this has to be also 1 unit. So it's right here at 2 comma 4. Okay, so I already know, so this is V2. I already know how it will look like. But I don't have the rectangle yet. I have to draw the rectangle, draw this asymptotes, and then the hyperbola. I'm missing something. So I know that C is 1. Sorry, not C. C is 3. I know that A is 1. So the distance between the center and the vertex is A. The distance between the center and the focus is always C. And now I need to determine, I know that B squared equals C squared minus A squared. I'm trying to determine B. C squared is 9. A squared is 1. Look at that. Again, B squared equals 8. So B equals 2 the square root of 2. So 2 times 141, so 2.8. So 2.8 left, 2.8 up and down from C. Right, so this is 1.41 times 2, 2.8. Okay. So we go 1, 2, 3 units up here. So 1, 2, 3 down here. Now I have the rectangle. It has to be between vertices, and in this case, B is this piece and B is this piece. So this is the rectangle. Now I'm ready to draw through the corner, through the center, through the corner, and continue the asymptotes. Corner, center, corner. Finally, I'm ready to graph the hyperbola. Here it comes. Through the vertex, nothing else. Asymptotically, vertex, asymptotically. Asymptotically, vertex, away. Asymptotically. This is the hyperbola. Now let's write the equation. We haven't written the equation yet. So, since the transverse axis is horizontal, I will have minus in front of y, not in front of x. A squared. A squared is 1. B squared is 8. So now, x minus the center, y minus the center, and this is it. X minus the x coordinate of the center squared over a squared minus y minus the y coordinate of the center squared over b squared equals 1. And this is